Assalamualaikum warahmatullahi wabarakatuh and very good. Salam sejahtera semua. Okay, today we will continue on analysis of variant part 2. Okay, previously we stopped at before assessing test assumption. So today we will continue with assessing test assumption. Okay, ANCOVA. Design make the same normality and homogeneity of variant assumption described for ANOVA design, and you can test the assumption using the same procedure described in section 9.3.2 previously. Okay, in addition, standard ANCOVA design assume homogeneity of regression slopes. In this case, it assumed that the regression slope for predicting birth weight for gestation time is the same in each of the 4 treatments group. Okay, here a test for the homogeneity of regression slope can be obtained by including a gestation dose interaction term in your ANCOVA model. Okay, let me see in R. Here, please run your code for the slide 47. Okay, here we have library Malcolm and fit 2. Here AOV is analysis of variance. We want to find the impact of weight from the factor gestation time times dose. Okay, from the data liter and the summary of fit 2. Okay, here please run. And you want to know what is the fit 2. Okay, here we can see that the interaction is not significant, supporting the assumption of equality of a slope. The assumption is untenable. You could try transforming the covariate on dependent variable using a model that accounts for separate slope or employing a non-parametric ANCOVA method that doesn't require homogeneity and regression slope. Okay. The p-value, okay, here. You can see that the value is greater. Okay. Let's back to the slide. Okay, on the visualizing the result, the ANCOVA function in the HH package provide a plot of the relationship between the dependent variable, the covariate, and the factor. Here you can see that the regression line for predicting birth weight from gestation time are parallel in each group but have different intercept. A gestation time increase, birth weight increase. Okay. Maksudnya dia berkaitan langsung. Okay, additionally, you can see that the 0 dose group has the largest intercept and 5 dose group has the lowest intercept. Okay, the line are parallel because you have specified them to be, if you use the statement ANCOVA, weight, gestation, time, dose. Instead, you generate a plot that allow both slope and intercept are vary by the group. This approach is useful for visualize the case where the homogeneity of regression slope doesn't hold. Okay, here, let us. This is the library HH just now. It's not in our. We have to install it. Then wait for the installation. Then library HH. Okay, here the ANCOVA weight gestation plus dose is equal to liter. Okay, you can see here the weight gestation time plus dose here. Where the from the 0 dose is the highest just now, like I said. has group the largest intercept, but the 5 dose group has the lowest intercept. 5 dose group. Here the lowest intercept. The line are parallel because you have specified them to be okay. For this approach is useful for visualize the case where the homogeneity of regression slope doesn't hold. Okay. Let's move to the slide. Here we want to see the two-way factorial ANOVA. In a two-way factorial ANOVA, subjects are assigned to groups that are formed from cross-classification of two factors. This example used two cross dataset in the base installation to demonstrate the two-way between ANOVA. Okay, the data has 60 guinea pigs are randomly assigned to receive one of 3 levels of ascorbic acid, which is 0.51 or 2 milligram, and one of 2 delivery method by using orange juice or vitamin C, under the restriction that each treatment combination has 10 guinea pigs here. The dependent variable is tooth length, which is we want to measure the impact on the tooth length. The following listing show the code for the analysis. Let's go to the R. Okay. We want to use the tooth cross data set just now. So put attach tooth cross. Table supplement and dose. Okay, ni orange juice and vitamin C, and this is the different dose it takes. Okay. And you want to know the tooth cross. Okay. This is the tooth cross. The measurement. This is the length with supplement vitamin C and dose 0.5 and we also have all the data. Vitamin C with dose 1, vitamin C with dose 2, orange juice with 0.5, orange juice with 1, orange juice with 2. And this is the length from the guinea pig. Okay. Okay, the table statement indicate that you have the balanced design, equal sample size in each cell and design. Okay, you can see that we have the balanced data here. Then we want to run aggregate. This is the length by listing supplement and dose. And function we use here is mean. Okay, here aggregate. Statement provide the cell mean and standard deviation. And after the aggregate, this is by using mean and this is by using standard deviation. And we want to know the head and the head of our data, which is the first 6. Okay, this is the first 6 data from the 2 scrolls. And we want to view 2 scrolls. Okay, we can find the view function view. It's okay. Just run the 2 scrolls. Okay, we want to view it. This is the 2 scrolls just now. And for the fit ANOVA, this is our this is the length is our dependent variable just now. We want to know the interaction between supplement and dose. And we want to know the summary. Indicate the both main effect, supplement and dose, and the interaction between these factors are significant because we can see from here supplement and dose. here is lower than 0.05. And after that, we want to know the interaction plot. We want to visualize. Okay. Interaction plot here. Library G plot. Okay, this is the interaction plot. This is a function to display the interaction into ANOVA. And here is the code. The resulting plot is present in this figure. The plot provides the mean dose length for each supplement at each dose. Okay. The red one is orange juice and the blue one is from the vitamin C, and both supplement for the 0.5 dose, 1 and 2 milligram just now. Okay, after that we want to do a interaction plot here by using library gplot, plot mean, length interaction between it. Okay, here. This is we do a little fineness to get interaction plot out of plot mean function in the gplot package. Okay. The graph include the mean as well as error bar. Okay, which is 95% confidence interval and sample size, which is we can see from the different supplement and with the dose here. This is the length just now. Let's get the length. Okay. Then we want to see the interaction. Interaction to WT from the length supplement times dose. Okay, let's run it. Okay. Here interaction to WW length supplement times dose. Okay. Again, this figure has been modified to display more clearer and look slightly different when you run this code. Okay. Yourself. Okay. It's different. Maybe you can get the different view, but all the graph indicate that dose growth increase with the dose of ascorbic acid for both orange juice and vitamin C. Just now we can see the increasing from the result. For the 0.5 milligram and 1 milligram dose, orange juice produce more dose growth than vitamin C. For 2 milligram of acid ascorbic, both delivery method produce identical growth of the 3 protein method provided. Okay, then here is interaction to WT, which is the in the package HH package just now. It's display both the main effect in the box plot and the two-way interaction for design of complexity and three-way ANOVA. Okay. Okay, here this is the thing that we plot just now. This is first display that we use, and this is the second one, and this is we want to view it side by side between by using interaction to WT just now. between the supplement and dose with a dose, and supplement and dose with the supplement. Okay, already discussed this. And we go to the repeated measure ANOVA. In repeated measure ANOVA, subjects are measured more than once. This section focuses on a repeated measure ANOVA with one within a group and one between a group. If you're confused with the terminology, please go previous slide in the first a few slides in terms of terminology. What is one within group and what is one between group? Okay, we'll take our example from the field of psychological ecology. Physiological ecology. Physiological ecology study how to physiological and biochemical process of living system respond to the variation in environmental factor. Okay, a crucial area of study given the realities of global warming. Here about the data, the carbon dioxide data set, CO2, include the base installation contain the result of study of cold terrain in northern and southern plant of the grass species, Echinoclea crasgali. Okay, this is from the research Potvin and Lekovic et al. The photosynthetic rate of chill plants were compared with the photosynthetic rate of non-chill plant. Okay, so we compare these two, which is chill plant and non-chill plant at several ambient. We have factor from the ambient of CO2. Okay, half of the plant will use Quebec and half of the plant from Quebec and half were from Mississippi. Okay, in this example, we focus on chill plant. The dependent variable is carbon dioxide uptake in the milliliter per liter, and the independent variable are type Quebec versus Mississippi, and ambient concentration of CO2 with 7 level ranging from 95 to 1000. Okay, this is between group factor and is and this one concentration is within group factor. Okay, meaning that the type from Mississippi here the independent variable is Quebec versus Mississippi is between group factor, and concentration just now is 7 level is within group factor. Okay, the analysis is present in the next listing. Okay, here let us run our R code. To the R. Okay, let us run it. Then we discuss about it. Okay, here is the W1B1 is the subset of treatment, and the treatment is chill. We want to focus on the chill just now, and we want to fit analysis of variant uptake, which is this is the dependent and this is the independent variable. Okay, the object update not okay. Don't highlight it. Just fit it. Okay, this is the summary of fit. We can say that this interaction is significant. At 0.01 level. Okay, we want to know the, okay, this is CO2 data. This is all the CO2 data just now. Okay. Then we want to plot a graph. interaction plot here. This is the graph. Between the different place and the different concentration just now. This is the interaction graph. And we can use the box plot to represent of the interaction in the same data. Okay, here let's do the box plot. Okay, from either graph, you can see that there is greater carbon dioxide uptake in a plane from Quebec compared from the Mississippi. Okay, just now the chill Quebec Mississippi plane. Okay. Uptake from the Quebec and Mississippi. This is from the Quebec 95 and Mississippi 95. Okay. See that the greater carbon dioxide uptake in the plane in the Quebec. You can see the difference here, and this is Quebec and Mississippi in the same level, which is 175. We can see that Quebec is higher than Mississippi. Also for the others. Okay, and here there's important thing, which is the data set. You work with typically in a wide format where the column are variable and row are observation, and there's a single row for each subject. Okay, the little data frame from the figure is a good example. When dealing with the repeated measure design, you typically need the data in a long format from fitting your model. In the long format, each measurement of dependent variable is placed in its rows. The carbon dioxide data set will follows this form. Okay. This is the one that we do in a R just now. Okay, the difference is more pronounced at higher ambient carbon dioxide concentration. Okay, let's go to the MANOVA, multivariate analysis of variance. If there are more than one independent outcome variable, you can test them simultaneously using multivariate analysis of variance. We have more than one dependent. Okay, the following example is based on the US serial dataset in the mass package. The dataset comes from Venable Replay 1999. In this example, we interested in whether the calories, fat, and sugar content of US cereal vary by store shelf, where one in the bottom and second in the middle shelf, and the third is the top shelf. Calories, fat, and sugar are the dependent variable. Okay, just now we said that MANOVA, we want to know the outcome more than one. Here the outcome is on the calories, fat, and sugar. And the shelf is the independent variable, which is we have the different shelves just now, 1, 2, and 3. Okay, the analysis is present in the following listing in the R. Let's do the R. Okay, we want to attach the US serial data, and you want to know the calorie, fat, and sugar. Why? And we can look at the US serial data closely. This is the serial name with their calories, protein, and fat. Calories, fat, and sugar. Okay. And if you want to look at the first 6 data, yeah, carbo, sugar, okay, and this is the sharp, and this is the content, and for the aggregate Y by least fun, and this is the mean function. Okay, this is the mean from the different sharp on the calories, fat, and sugar. Okay, this is co-function provides the variance and covariance across series. And you want to fit MANOVA. And summary of this fitting. Okay, from what here it's provide multivariate test of group difference. The significant F value indicate the G group differ on the set of nutritional measure. And its difference, we can see here is because of the P value is less than 0.01. And because of the multivariate test is significant, and we can see the summary of analysis of variance from the fit. Okay, this is the summary of it. Okay, from the sharp and residual, we can see here. And from the, okay, this is the response from the calories, it's significant. And response from the fat, and also response from the sugar. Okay, this is the 3 group differ on each nutritional measure, consider this it separately. Okay, can see use mean comparison procedure. Okay, or we want to save a space here, we can use the Turkey HSD function. Okay, let's move to the slide. Okay, this is the one that we run just now. For the assessing test assumption, the two assumptions underlying a one-way MANOVA are multivariate normality, homogeneity of variance covariance matrices. The first assumption states that the vector of dependent variable generally follow a multivariate normal distribution. Okay, can use a QQ plot to assess this assumption. On the theory, if you have P times 1 multivariate normal random vector times with mean, mu, and covariant matrix, then the squared Mahalanobis distance between x and mu is the chi-square distributed with the p degrees of freedom. The QQ plot graph the quantile of the chi-square distribution for the sample against the Mahalanobis d-squared value to the degree that the point fall along a line with slope 1 and intercept 0. That's evident that the data is multivariate normal. Okay, in the data follow a multivariate normal distribution, the point will fall on a line. The identity function here allow you to interactively identify point in a graph. Here the data set appear to violate multivariate normality primarily due to observation for wedges, honey gold, and wedges. Okay, let's do it in R for assessing test assumption. Okay, this is the center and row 1, we, just this is where we define a variable for n row y as an n, and row column y as a p, and COV is from the COVY. We define a variable, then we use Mahala Nobis to the center and covariant, and this is for D. Okay. Okay, this is where we do a QQ plot. And we get this graph. And we want to use the identity just now, right? A B line 0, B is equal to 1. We run identity. Okay, here we can use the function x, and this is the identity. The homogeneity of variant covariant matrix assumption require the covariant matrix for each group are equal. The assumption is usually evaluated with a box M test, and R doesn't include the function box M. But the internet search will provide the appropriate code. Okay. Unfortunately, the test is sensitive to violation of normality, leading to rejection in most typical cases. This means that we don't yet have a good working method. Okay. We finally get the test for multivariate outlier using AQ-plot function. Okay, from the MV outlier. Install the package, and we want to plot the MV outlier here. Then we can see this is the graph that we have from the cumulative probability, and this is outlier based on 97.5 quantile. Okay, this is the outlier based on adjusted quantile. This is the adjusted quantile, and we filter it, the outlier we get here. And object outlier. Actually, we already, okay, this is, we define outliers, but we call outlier only. We have to put S at N. Okay, this is the outlier, which is the false, the true in the line 30, there's an outlier, and 25, there's an outlier from the true. One also have a outlier. Okay. And let's move to the slide. And this is the one that we do just now. And we outline package, and we move to the robust MANOVA. If the assumption of multivariate normality or homogeneity of variant covariant matrices are untenable, or if you are concerned about multivariate outlier, you may want to consider using a robust or non-parametric version of MANOVA test instead. Okay, a robust version of the two-way MANOVA is provided by the weak.test function RRCOV package. But furthermore, Adonis function in the vegan package can provide the equivalent of non-parametric MANOVA. And the listing weak test we have from our example here. Okay, let's run it first. Okay, this is where we install the library package rrcov and we test. Let's wait because it's still running. Here, the symbol. Let's wait. We want to see the robust one-way maneuver result. Yeah, this is the result. From the result, you can see that a robust test that insensitive to both outlier and violation of maneuver assumption. The p-value. Okay, here. Okay, from the post outlier and violation of maneuver assumption, it still indicate the serial on the top. Middle and bottom store shelf differ in their nutritional profile. And it's differ. Okay. Okay, ANOVA as a regression. Here in this section, in section 9.2, previously we note that ANOVA and regression are both special case of the same general linear model. As such, the design in this chapter could have been analyzed using the linear model function, LM function. However, in order to understand the output, you need to understand the R deal with the categorical variable when fitting model. Consider the one-way ANOVA problem, which compare the impact of 5 cholesterol reducing drug regimen, TRT. Okay, let's do it. ANOVA as a regression here. We call the library Malcolm. And we want to see the level cholesterol in a TRT file. Focus on the TRT. Okay, here is the level 1 time, 2 time, 4 time, drug D and drug E. Then we fit analysis of variant and we want to know the summary of it. Okay, here. Okay, now let's find the same model using linear method. Okay, this is fit and this is the cholesterol data. Just now we are using analysis of variant. Now we want to fit using linear model. A summary of linear model fitting. Here is the interaction between TRT with 2 time, TRT with 4 time. Okay, and TRT with drug D and drug E. Okay. This is significant because of the significant is this is where the 1 star is less than 0.01. Okay. The result is significant. Okay, we fit the contrast first. This is the contrast cholesterol in the TRT. And we fit the linear model, and this is the summary of fitting. Here, what is it? Because linear model require numeric predictor when the linear model function encounter a factor, it replaces the factor with a set of numeric variable representing contrast among the level. If the factor has k level and k plus 1 contrast variable will create it. I'll provide 5 built-in method for creating this contrast variable. Okay, you can also create your own. The treatment contrasts are used for unordered factor, and orthogonal polynomial are used for ordered factor. Okay. In the contrast just now, here, contrast. Okay, if the patient in the drug D condition, then the variable drug D equal to 1. This is drug D equal to 1. Then the variable 2 times, 4 times, and drug E will each equal 0. You don't need a variable for the first group because a 0 on each of the 4 indicator variable uniquely determine the patient is in the 1 times condition. Okay, here TRT 2 times. Okay, here represent a contrast between the level 1 and 2 times. Similarly, TRT 4 times is in a contrast between 1 time and 4 times and so on. You can see from the probability value in the output that each drug condition is significantly different from the first time. Okay. Okay, you can change the default contrast in the linear model by specifying a contrast option. For example, fit. Okay, fit LM response. TRT data cholesterol. Okay, this is where we use we change by specifying contrast option, which is cont.helmet. In a summary here. Okay. Actually, in a contrast, you can change by using your preference, whether you want to use what option you want to use. Okay, you can change the default contrast by using R session via option. Option contrast C contrast dot S. Okay. You may find what is other contrast option in R. Okay. This is the ANOVA as a regression just now, and this is where we get the value from the code. Analysis of variance just now is here, and this is where we set a linear model. This is the thing that we discussed in R just now. Okay, this is built-in contrast option, whether it is contrast.helmet, contrast.poly, and this is the description where you can use what option that you want to use. And this is the one that we run in a R just now and finish with our analysis of variant part 2. This analysis of variant part 1 and part 2 you may use in the assignment later on. And after that, we get a final exam. Also, one question from this analysis of variance. What can we assume from the result? But you no need to calculate, but I'll give the table. And from the significant levels, you may conclude something. Okay, what assumption can you make uh, from the result, and what from the code, what is the factor? The question is like that. Okay, but later on I will put how can we find a significant value by calculating it. Okay, that will be an exercise later on that you need to submit. But this exercise, after Dr. Fauzia class, I will give the exercise. But I need to teach you manually how to do a written calculation to get the result. And this calculation, I give one question, then you may submit in exercise later on. But let's finish this ANOVA part 1 and ANOVA analysis of variant part 2 to focus on your assignment and your final first. Okay. If you have a question you want to ask, you may ask me through the WhatsApp, or maybe we can meet later on. Okay, I'm stop sharing first. Okay. Until then, thank you and Assalamualaikum.